All right, so today we're in section 10.4, talking about the law of sines. So, so far what we've done with trigonometry, with our sines, cosines, and tangents, has to do with right triangles. We had a 90-degree angle, and we came up with our trig ratios because right triangles with a particular angle were all similar. So we could make our ratios, and they were the same no matter what size our triangles were. Well, the law of sines, and tomorrow we'll talk about the law of cosines, gives us a way to work with triangles that don't have a 90-degree angle in them. So first we need to draw our triangle and talk about how we label these triangles. So we have a triangle. It's not a right triangle. It's nothing particularly special about it. It's just a triangle. We normally label the angles with capital letters. So I'm going to label this A, B, and C. And we label the sides with small letters opposite the angle. So this is angle A. This would be side A. This is angle B. This would be side B. This is angle C, so this would be side C. So normally when we're working with triangles, this is how we label them. And none of these angles are right angles. So the law of sines tells us that for any triangle ABC, and our sides, so we're going to say any triangle ABC with sides, little a, little b, and little c, we have these equations that are always true. The sine of angle A over the side A equals the sine of angle B over side B equals sine of angle C over side C. So no matter what the angles are, what the sides are, the sine of the angle A divided by the length of side A equals the sine of the angle B divided by the length of side B, and that also equals the sine of angle C divided by the length of side C. So this is the law of sines. The quiz that we're going to have on Monday includes law of sines. You're going to need to memorize the law of sines. So you need to memorize SOHCAHTOA, which trig ratio to use. You need to memorize law of sines. We'll have law of cosines tomorrow. You also need to memorize that. Law of sines comes from dividing this triangle into right triangles and using what we already know about right triangles to show that these equations are true. Questions on law of sines, the way we've written it, what it means, how we label our triangles? Okay, what we do with law of sines is what we call solving triangles. And solving triangles just means find all the missing parts. If you get a problem and it says solve the triangle, it's just asking you to solve for all the parts that we don't have. I'm just going to put that in parentheses here. So we use law of sines for solving triangles, and there are two types of triangles that we use law of sines for. So we use law of sines for 1. When we have 2 angles in one side, so when we have a triangle and we know 2 of the angles in one side, and the second case is 2 sides and an angle opposite one. And normally, when we have 2 angles in one side, we're talking about an angle-side-angle triangle. And when we have 2 sides and an angle opposite, we have a side-side angle. So just using the way we labeled or talked about triangles before and how we could show that triangles were congruent, this is one way you can think about it, when we have an angle-side-angle or when we have a side-side angle. So we'll use the law of sines to find missing parts of triangles, just like we've done with sine, cosine, and tangent. This just gives us another tool. Another important thing to remember about the law of sines is that it gives us 3 equations. So there are a lot of things we can work with. One of our equations just comes from the first combination. Sine A over the length of side A equals sine B over the length of side B. The second equation comes from sine A from this part and the last part. So our second one is sine A over the length of side A equals the sine of C over the length of side C. And our third equation comes from these two. So our third equation is sine B over the length of B, and that equals sine C over the length of side C. So those are our 3 equations from the law of sines. So it gives us a lot of possibilities that we can work with. So questions on law of sines, questions on our equations. So what I want to do today, what we're going to do is I'm just going to do a couple of examples of how we use the law of sines. So let's look at those examples. So our triangle. We have a triangle that looks like this. And we'll call this angle A, angle B, and angle C. This is side B, this is side A, and this is side C. And we know that this angle is 25 degrees. This angle is 70 degrees. And we want to find, and we know that A equals 3. And our problem is to find length B and length C. So I look at my triangle. I have 2 angles and a side. That tells me I can use law of sines here. So let's set up one of our equations for the law of sines. I know angle A and I know side A. So I'm going to pick that for the first part of my equation. I know angle A and side A, so I'm going to say that the sine of 25 degrees divided by 3, sine of angle A divided by side A, equals, and let's find side B first. Since we know angle B, we have the other part of one of the equations. So I'm going to say that that equals the sine of 70 over B. Sine B over the length of B. So when I solve these equations, the way I like to do them is I like to solve them first and then plug into my calculator. So I'm going to do it that way, and then I'll backtrack and say how we could do it another way. So here we have a proportion. To solve this, I'm going to cross multiply. We'll cross multiply here, and I get b times the sine of 25 degrees equals 3 times the sine of 70 degrees. Now I want to get b by itself. We're solving for what we want. So I'm going to divide by the sine of 25 degrees. And when I do that, these go away. And I get b equals 3 times the sine of 70 degrees divided by the sine of 25 degrees. Now I've got b. Now I would plug this into my calculator and calculate this. But if I plug this into my calculator, I get this is about 6.7. Now the other way I could have done this is, starting from here, I could plug sine 25 into my calculator and divide that by 3 and just get a number here on this side, and then solve the equation that way. I could just have a number here. If you do that, if you find the sine of 25 and get a number, divide it by 3, when you find the sine of 25, you should use at least 4 decimal places when you find the sine of 25 degrees. So if I plug this into my calculator and I say, I'm going to find the sine of 25 here. So sine 25 degrees, I get 0.4226. If I just use 0.4 for the sine of 25 degrees, your answer at the end could turn out being quite a bit wrong. So use at least 4 decimal places when you use an intermediate step and find the sine or the cosine of a number. I like to solve everything and then plug everything into the calculator at the end. All right, so now we found b. b equals 6.7. So we know this is 6.7. We found that here. Now we need to find side c. Well, we know we already used sine 25 over 3, so we'll use that again. To find side c, we need to know angle c. How can we find angle c here? 25 plus 70 minus 180. All the angles in my triangle have to add up to 180 degrees. So I'm going to do c equals 180 minus 25 degrees plus 70 degrees. So I'm going to add 25 and 70, subtract that from 180. That tells me that angle C is 85 degrees. Now I can use another equation for angle C and side C. And I'm going to use this again since we already used it. So sine of 25 over 3 equals the sine of 85 over side C. Cross multiply, I get C times the sine of 25 degrees equals 3 times the sine of 85 degrees. And divide both sides by sine 25. Those cancel, and I get C equals 3 times the sine of 85 degrees divided by the sine of 25 degrees. Plug that into my calculator, and I get C is about 7.1. So now I've found side B, side C. I'm going to go up here, put C equals 7.1. And we found that angle C is 85 degrees. So we've solved our triangle. We know all the parts of the triangle. So we use the law of sines twice on this triangle. Questions on what we did there? Now on the quiz, you won't have to figure out whether or not to use law of sines. The problem will say use law of sines to figure something out. So it'll tell you to use law of sines or to use law of cosines or to use sine, cosine, tangent. All right, let's look at another example, slightly different this time.
Can you go back to the
Sure.
What do we got?
Someone needed to look at it for just a second more. Are you good?
Yep.
Okay. So our next example. For this one, our triangle, here's our triangle. And we're going to use X, Y, and Z for our triangle this time. We don't always have to label our triangles with A, B, and C. So this is going to be side Y, this is going to be side X, and this is going to be side Z. And we want to find measure of angle X.
Plus.
So we don't know angle X, and let's see, what else do we know? We know Y equals 30. And this angle is 45 degrees. And X equals 25. So in this triangle, we have two sides and an angle opposite one of the sides. So we can use law of sines. We have angle Y and side Y, so that one is definitely going to be in our equation. So let's start by writing one side of our equation with this angle and this side. So we have sine 45 degrees over 30. And we're interested in angle X. So I'm going to write my second part of my equation with angle X in it. That is sine of angle X over side X, 25. So this is my law of sines equation for this particular triangle. I want to find angle X, so I have to get sine X by itself. So I'm going to multiply by 25. And I'm going to rearrange. So I get sine X equals 25 times the sine of 45 degrees over 30. Those cancel. And I can plug this into my calculator and get a number here. So if I plug 25 times the sine of 45, divide that by 30, I get sine X equals about 0.5893. And when I do this, I want to keep about 4 decimal places because my answer can be off by quite a bit if I don't keep enough decimal places. So the sine of X equals 0.5893. I want to find angle X, so what do I have to do here? Inverse. We're looking for the angle. To find the angle, we use the inverse. So X equals the inverse sine of 0.5893. Plug that into my calculator, and this tells me that X is about 36, angle X is about 36 degrees. So we wrote our law of sines with the parts of the triangle that we knew, solved for the part that we didn't. We were looking for an angle, so we had to use the inverse sine. Now let's think back to our opener. We said that our calculator would tell us one angle, that's that one possible angle here. But how many angles are there that could have this same sign? Don't we have two possible angles? Isn't that what we did in our opener? One was, our calculator told us one, the other one we subtracted from 180 to get the other one. So there's two possible angles. So what I want to, we're fine in this particular problem, but there are cases, and I want to talk about them. We're not going to do a lot with them, but you'll see them in Algebra 2, and you'll see them in pre-calculus. There are cases when you can come up with more than one possible triangle, and that's called the ambiguous case. I just want you guys to be aware of it. The ambiguous case. Sometimes when we're using the law of sines, we can get two possible triangles. Because when we take the inverse sine of an angle, we have two possible angles. The ambiguous case comes when we have two sides in an angle, and depending on the arrangement of the sides, we can arrange them into two possible triangles. So let me draw the possibilities here. We talked about this last semester when we talked about why side-side angle didn't work for showing that triangles were congruent. So that's my angle. We're going to say that's side A and that's side B. We can make, depending on the lengths of side A and side B, we could get a triangle that looked like this. My angle is the same. This is the same angle. This side is the same, and that side is the same. So we could get two possible triangles for one angle and two sides. And this is called the ambiguous case. When we solve the ambiguous case, you end up with two possible angles for this angle, and two possible angles for this angle, and two possible lengths for this third side. Like I said, we're not going to do a lot with it. You'll see it again in Algebra 2, and I know this year in pre-calc we did a lot with the ambiguous case. So I just want you to be aware that it exists, so that it won't be the first time that you've heard about it when you work with it again. Questions on law of sines? All right, so like I said, on your quiz that's coming up, the problem will tell you use law of sines to solve this problem. So you'll have that part, but you'll need to know the law of sines. Okay.